All right, so 4.3, another form of the equation for a linear relation. Okay, so we're talking about linear relations, linear equations, and now we're going to talk about different forms of linear equations. So we're going to get some more work on graphing. We're going to get some more work on plotting points, connecting lines, showing the graph. And in math, high school math, university math, any math that you take, equations of lines and curves and different kinds of graphs are super important to understand. And so this is the basic, the easiest kind of equation to look at, and the easiest kind of graph is a straight line graph. Okay, so we're going to continue studying this. Very, very important. All right, so we're going to start off by just doing some examples. I'm going to do this with you. So for each equation, we need to complete the table of values. We need to graph each line on this coordinate grid provided and describe each relation. Okay, so these are the three things we're going to tackle here. I've got a couple examples to work through here with you today and some other things to do, but let's start with this one. So how can we complete the table of values? Well, we are given some x values to work with, right? And hopefully you remember, if we need to turn lights off, go ahead if you guys can't see that. But hopefully you remember that the x values are like the input values, right? Those are the ones you put into the function sort of machine, I call it. And the function machine kind of like, it rolls it around and it kind of makes some noises and chuffs some smoke and then it spits out a y value, right? That's kind of what happens. You put in an input and then there's not a lot of work that's being done on this equation, but it'll give you a y value. So we literally do this. We take the x value, and I'll get you to show some work here for the first few anyways. We're going to put the x value in where we see x. So this one's going to be, we're going to solve for y. So y equals negative x. You see that? So I'll zoom in for this. And the x is actually negative 2. So we have to be very careful that we put in all the appropriate parts. The negative sign is outside of the x. The x actually has its own negative, so there's a double negative there. So we'll have to remember that. And then plus 2 on the outside. So I've put x in. I'm going to let the function machine do its bit. It multiplies this number by negative 1, and then it adds 2 onto that. So y is going to be positive 2 plus 2. Y is going to be equal to 4. Does that sound good? Okay, so we put 4 right here. So the first point is negative 2, 4. Okay. Now we don't really have much. I mean, maybe some of you are able to look at this equation and understand and say, I know exactly what happens now. I can put the rest of the values in pretty quick because you're recognizing patterns, and that's great. But probably we're going to have to just put some more x values in until we see a pattern emerge. Because remember, this is a straight line, so we should have a consistent pattern between each number. Okay? Because this one goes up by 1 each time. So we know that we're going to have a consistent pattern here. It's going to be awesome. Okay, let's try negative 1 now. And I'm going to put negative 1 in here. And I'm going to just cheat a little bit because I'm just going to erase my negative 2 and I'm going to put negative 1 in there. And so negative times negative 1 is going to be positive 1. Plus 2 is going to be 3. Okay, so I put a 3 in there. All right, hopefully everything's going well here. Now, anybody have any idea what the next y value would be if we don't show the work here? Any guesses? 2. Yeah, you're absolutely right. It is 2. Let's give that a quick check. And you don't have to show this if you don't want to because you don't have to do every one. But negative 0 is just 0 plus 2 is 2. So yeah, 0 in there, you get a 2. Now we can see for sure that we're going down by 1 each time. Awesome. And if you remember from the last few days of our work, this number in front of the x, you see that? That number is negative 1. And so because this is plus 1 and plus 1 and plus 1, negative 1 divided by positive 1 is going to be the number that we put in front of the x. So that all should make sense now. And we can keep finishing the table of values just with the pattern. So we subtract 1 each time. That's a 1, and this is a 0. Okay? Any questions about that table of values? Okay, so you should be able to do that Make sure that you put the x into the x position there, solve for y. Do that 2 or 3 times to make sure you can establish a pattern before you just start guessing on the numbers. All right, so complete the table of values, done. Graph each line. All right, here we go. Let's put some points down. -2, 4 is our first point, and if you want to just show it like this, that'd be great. -2, comma 4. That's the point. We go straight across the rows there in the table of values. Those are the coordinates that go together. So we always start at the origin, remember? And we go left 2 units, and we go up 4 units, and we plot a point. So over 2, up 4. The next one, to the left 1 and up 3. Then we go left or right 0 units and up 2. And you can kind of see what's happening here. We are forming a little bit of a straight line. 1, 1 is going to be here, and 2, 0 is going to be right there. Okay. Now, you will need a ruler or a straight edge of some sort to put a line through all these points. Okay. So if you don't have a ruler or straight edge, if you need to borrow one, I do have some rulers available. But you're going to put a straight line right through these points, and you can extend it through because, of course, we could put a lot more points on this table of values, right? So go ahead and do that now. All right, so there's a straight line through all those points, and that's what that graph looks like. Okay? Now describe each relation. So describe each relation. So for now, what we'll do for 3 is we'll describe the patterns that we see in both the table and in the line. So let's tackle that. So for number 3, a good description at this point would be as x value increases by 1, y value decreases, because it goes down, by what? By 1 as well. So x increases by 1, y decreases by 1. And we can look over here and see that for every point that we give, as the x value increases, that means we go to the right 1 unit. We have to go down 1 unit to place the next point. Okay? So that happens every time, and that's a great description of what's happening. Okay, do you guys know, do you remember, I think I mentioned this before in class before, but do you remember what this 0, 2 point is? Do you remember what's special about this point? What is this point right here, do you remember? Anybody know what the name of this is? It's what's that point 0, 2? There's a special name for that one. Anybody remember? It's the y-intercept. Anybody remember that? Did I talk about that with you guys? I think I did. So it's the y-intercept. So that's where the graph intercepts the y-axis. And straight lines, well, all functions will only have one y-intercept. And straight lines will also have one of these. What's this point right here? 2, 0. What's this one? Very good. It's the x-intercept. Okay. X-intercept. All right. So intercepts are very important in math because in math problems, hey guys, answer yourself. In math problems, intercepts represent some very foundational things in word problems. So those are really important. And also the steepness or the slope of the line, which we'll talk about today, that's very important too in a lot of different examples. All right, let's do another one. And actually, I think I have trust in you guys. I want you guys to try and fill out this chart. Take a minute and try this one on your own. You're given an equation right here. So go ahead and do exactly what I did up here by placing the x value, first x value you see, in place of the x in the equation and try and find the y value. So take a minute and fill in this table of values, and then I'll do it behind the scenes and unfreeze the screen, and we can compare our answers. Okay? So go ahead and take a minute to do that. All right, so I filled in the table of values up here in the board. You guys can take a check. I would like you to show your work and how you calculate the y value. This took me literally 45 seconds to do. It's not a big deal. If you do that fairly carefully, you can get be a little more confident with your answer. But let's just see. So 3 times negative 2 gives me negative 6. Minus 1 would be negative 7. So that's why I put negative 7 for a y there. I did the second one as well. 3 times negative 1 is negative 3. Minus 1 is negative 4. So I put the negative 4 there. I noticed that each of the x values are increased by 1. And then I started noticing that, hey, we've got a plus 3 here, and for the third one. So I just continued that pattern. And negative 1, 2, and 5 are the last ones there. Okay, so let's graph it. So negative 2, negative 7. So I start at the origin, go over negative 2 to the left, go down 7. I plot a point. I go negative 1, negative 4. So that's over 1, down 4, plot a point. 0, negative 1 is right there. 1, 2, 2, 5. 2, 5. Okay? So that's what those points look like. And they are in a straight line, right? They're in a straight line, which is great because this is a straight line. And if we connect those points with the lines, let me see if I can do that rather quickly here. This is, again, it's always a bit tricky to get this lined up properly, but I'll do my best here. Come on now. Okay, so somewhere right around there. So that's what your line looks like. And again, I want you to notice something, that the line is going uphill from left to right. We always kind of think about the line, think about left to right. It's going uphill. The last one was going downhill, right? It's going downhill. This one's going uphill. So what do you notice about the equation here? In the one that's going downhill, well, what we notice is that the number that's multiplied by x is negative. And so that line runs downhill. This one is positive. The number on the x is positive. That runs uphill. Okay, so that's going to be pretty important to remember. The description of this one for point 3, let's talk about that. So we'll write that down there real quick. As x increases by 1, y increases by 3. So if you go over 1, you go up 3. The same could be said, you could write this in the opposite order. As y increases by 3, x increases by 1. You could say it that way too. I usually start with the input variable first, but you can start with the y variable. And as a matter of fact, starting with what the y does, and then saying what the x does is going to be very important later on when we're calculating the steepness or the slope of the line. So as y increases by 3, x increases by 1. And that happens every single time. And you can do that as many times as you want, and you always get the next point on the line. And guess what? This would be the next point that we didn't graph. And I could go up 3 and over 1, and there would be another point up there that would still fall on that line if we extended it. So the 3, right? The 3 divided by 1, as I mentioned before, is pretty important because 3 divided by 1 is 3, and that's the number attached to the x. 1 divided by 1, negative 1, because it's decreasing here, divided by 1 is negative 1, and that's the number that's multiplied by the x. Okay. Any questions about this first page, the first couple examples? All right, it's super important. So we will be revisiting that in your notes and like that, but let's continue on here. So the lines that we're talking about here, okay, and these are the picture of the 2 lines that we would have graphed here just now. The 2 lines we're talking about are called oblique lines. Oblique is the word there, oblique lines. This means that they are slanted. Okay, oblique. So oblique is slanted. And actually, I don't know if you guys knew this, but in your body, the side muscles, you have actually muscles in your abs, right? You have muscles in your pecs and all over the place where you have muscles. But you also have muscles on the side of your torso here. Those are called your obliques because they're slanted. Okay? Now, for me, they're slanted the wrong way. They kind of go out like this. They're supposed to go in but that was a joke because I'm old and getting chubby. But obliques are slanted, okay? So they're oblique, okay, slanted. Now, they can slant in either direction, thankfully. They can go up from left to right, or they can go down from left to right. And again, I always refer to from left to right because that's pretty important, because that's what's going to be that's going to be important for looking at the number in front of the x there. That's going to tell you whether it's going to go up or down. Okay, so they can slant in either direction, and they can have different slopes. So if you think about the slopes, that is steep or not steep. Okay, so this would be a lower value slope than this one. This one's very steep, so the number itself is going to be very high. Okay, and we'll talk more about that as we continue here. The equations will always contain two variables, so we kind of know that from before. And when the independent variable increases by 1, as we've seen in these two examples, and the dependent decreases, the line will slant down. So if this is negative, as I just mentioned, we will have a negative slant or a negative slope. So if this number is negative, the line is going to go downhill from left to right. All right? So think about, I can't really draw. This just came to me now, but let's just say I can draw and see if you can figure out what's going on here. Okay? All right, so this person is definitely skiing downhill. You see that? That's a stickman skiing. Sticks all over the place. Sticks on his feet, sticks in his hand. His hands are sticks, everything sticks. So he's skiing downhill, okay? So negative slope, downhill. This one, going uphill. So we got another stickman here, and let's see if I can do this. This stickman is climbing the hill. It's not too bad, eh? Look at that. Yeah, actually I'm pretty impressed with myself there. That's a pretty decent drawing there. See that? See climbing up the hill? You like that? That's not too bad. Yeah, thank you. Thank you for the applause. Thank you. Extra marks for you, and you. Thank you. Okay, good. Extra credit. Oh, okay. Extra credit for you as well. Oh, thank you. And you. That's right. That's the sign of a true entertainer when they have to bribe the audience to cheer for them. That's true. Yeah. Okay. All right. So when the independent variable increases by 1, because we're still talking about this increases by 1, independent, and we have the dependent variable increases as well, then we have a positive number here, and it will slant upwards. Okay. And which of the lines are steeper? Well, we know that the second line is steeper, okay, regardless of the direction, right? It can go either direction, but which one is steeper? So the one that climbs the quickest or that falls the quickest. So the second line, right? The second line is steeper. And the actual value, regardless of the sign, if you don't think about positive or negative, the value, the number itself is larger for that line. That's the 3 versus just the 1. And again, I'm not talking about positive or negative now, but the actual, it's called the absolute value of the number. Have you guys ever heard absolute value before? You guys know what that is? Seen some nodding? Okay, so the absolute value of a number is just the magnitude of the number itself without any regard to its direction or its sign. So in science, direction and magnitude as well as a unit is very important to describe sort of, some kind of, it's called a vector quantity. But if we're talking about the absolute value of a number, that's just the value of the number, the size of the number itself. And so the absolute value of the number is larger. That's a steeper slope. All right. Questions about that right there? Okay. Positive slope, negative slope. Very important. Super important. Okay. Notice that these two lines are in the same form. Let me talk about forms of a line. Okay. We have two variables. All right. Always two variables. And commonly it's going to be y and x because that's what the axes are labeled. But this is the most common form that you will see for a line. This is called y equals mx plus b Or this is the slope-intercept line, slope-intercept form. So let's label that, okay? That's not in your notes, but this is called the slope-intercept form. Or some people call it the slope y-intercept form. Slope-intercept form. And I think I probably call it the slope y-intercept form more often, so I'm going to write that too. But slope y-intercept form. Y equals mx plus b. Very common for a line. And that's because you see how this number that's multiplied by the x is actually given a variable here? Well, that m refers to the slope of the line. It refers to what direction it's either climbing or falling, and it refers to how steep it is. So a small number would be just barely uphill like this, right? A very small positive number. This would be a large positive number, like super steep, like you couldn't climb up there. Okay? This would be down here just a small negative number, just like a gradual slope, and then a very large negative number. See that? So that m is important. And in this form, you just take a look at the number that multiplies by x, boom, that's your slope. And this b is also very important. And I don't know if we highlighted this yet, but this is super, super important. That, look at the number here, the b value, the constant, plus 2. What do we notice about plus 2? Well, it's the y-intercept. It actually happens to be the x-intercept too, but look over here. Look at this one, -1. Which one is that? Well, that is the y-intercept. So this constant is very important as well. And the b is the y-intercept. So maybe we'll just take a moment to note that as well. So m here is the slope of the line. M is the slope of the line in this form. And b is the y-intercept. Okay, so please make sure you jot that down. It's not in your notes, but you can jot that down. Okay, so as you see in this example too, this is not the same form. This is not slope y-intercept form, okay? That's something different. So this is called standard form of a line. Standard, where we have the x and y values on the same side of the equation and the constant on the other side. So this is technically called the standard form of a line. Standard form. But this is just as valid as the slope-intercept form. Now, we can't look at the number in front of the x in this form and say that that's the slope of the line. This is the only problem. It's not going to be that, okay? It's not going to be the case. But let's work with this line, and let's see if we can still complete the table of values here. And it's going to be easy, because we're given an x, so I just have to solve for y. I have to figure out what y is. And this is going to be pretty easy. So let's go ahead and do that. So -2 is in for x, plus some value y has to equal -5. You could probably do this in your head, and we'll see if we can do that in our heads right now. And then I'll show you how we can move things around to solve for y. But what do I have to add to -2 to get -5? Anybody know? Okay, is it -3 or +3? So we are, here's the number line. Well, here's a number line. Here's 0. If we start at -2 and I have to get to -5, I have to add a -3. Yep, so y is -3. How do you, oh, disappear. How do you know that for sure? Well, all you do is try and get y all by itself and find out what it's equal to. So we're going to do the opposite operation of this -2. We're going to add 2. And for an equation, what you do to one side, you absolutely have to do to the other. So now these are going to add up to 0. This is still a y on this side. -5 plus 2 is -3. That's our answer. Okay? And if it helps, you could move this into slope y-intercept form right away and then work with that. You don't have to, but you can. Okay. So let's do the next one. -1. What do I have to add to -1 to get -5? Well, we have to go left 4 more units from -1 to get 5. So this is -4. Okay. What's going to be next, do you think? This is all going up by 1 each. We have a little bit of a pattern here. We go -1, Let's just double check. So 0 plus y equals negative 5. So y is negative 5. Yeah. Okay, so we are subtracting 1 each time. Negative 6, negative 7. You guys okay with that? Awesome. So we can use other forms of lines to still populate a table of values. And of course, these are just regular old points. So we'll just plot those points here. And we have negative 2, negative 3. So from the origin, negative 2, go down 3. Looks like it should be a point there. Negative 1, negative 4, and so on. And yeah, why don't we just go ahead and plot those points and connect them with a line. Okay, so that's what your line could look like. Just a couple notes. How far you extend the line doesn't really matter so much. But please put arrows on each end. Okay, you need to put arrows on each end because this relationship holds true for numbers that are far smaller, like more in the negative direction, and far larger than is shown on this graph. So this line would continue in this direction really forever. So you have to put an arrow on each end. Okay? Yeah. Okay. Describe each relation. Okay, so if we were describing this relation, as the x value increases by 1, the y value decreases by 1. Increases by 1, decreases by 1. Maybe I'll just type that. As x value increases by 1, the y value decreases by 1. And of course, you should be understanding now that that gives us a slope of negative 1. Okay, so negative 1 is the change over here, and positive 1 is the change over here. So the slope, which equals the m value in our slope y-intercept form, is equal to negative 1 divided by positive 1, or negative 1. And if I move this equation around so that it's in slope y-intercept form, it's going to be pretty easy to do. And all I have to do is get y all by itself and positive. And I'm just going to subtract x here from both sides, which makes this into y is all by itself now on the left side. Those are gone because they add up to 0 now. And I have negative x minus 5. So guess what? The slope is negative 1, and I know that now. What's the y-intercept again? What's the y-intercept of this line? The y-intercept would be the point that's on the y-axis, and that's this one right here. 0, negative 5, and guess what? Negative 5 is my b value. That's the y-intercept. Okay, I can't overstate the importance of knowing the slope and the y-intercept here, okay? Any questions? Okay, what percentage of this would be new to you, brand new? Like a big percent or a small percent? Small or big? A little bit? I'm seeing most people like say kind of small. So most of this you've seen before? Mid? Yes. Mid? 50-50? 50-50? Okay. All right. All right. Let's keep going. We are almost done. Almost done. Let's get through this page here. And we're almost done. Okay, so let's go ahead. This looks a little bit funny. Actually, on your paper, let me just see. I think that there's a typo. Yeah, it's this. It should read like this. Midway through your last page here in 4.3, there should be no squared on the x. I'm not sure where that squared came from. There's no squared on the x, so just erase that or cross that out. It's just ax plus by equals c. So that's the, again, we said that's the standard form of an equation. Okay. Now, here's where we actually do need to rearrange or rework the equation a little bit in order to solve for y. So let me just show you again how to do that. I'm going to put negative 4 in for the x because it's in the x column. So I'm going to do 3 times negative 4 minus 2y equals 6. This is a super important skill for you to know how to do. In order to solve for y, we need to get y all by itself and positive. So when we get into chapter 6, you need to know how to do this. And we're going to be doing a lot of this stuff, rearranging equations. So let's get some more practice. What I would do is simplify anything you can first. I'm going to write this as negative 12 minus 2y equals 6. Simplify one thing at a time, rewrite whatever you don't touch, okay? Now I'm looking at this y right here, and I need to get this all by itself and positive. So I'm going to start to peel away everything that's the furthest away from y. I'm going to get this over to the other side. And then I'm going to work on that negative 2 there. So one step at a time. How do I get rid of the 12? But add 12 to both sides. That will yield a 0 there on the left. So we have no more numbers over there on the left. I have negative 2y equals, what's 6 plus 12? 18. Okay. Notice how I'm keeping my equal sign in a nice straight column. I'm trying to keep the terms in a nice straight column too as best I can, so that this is all looking fairly neat. The reason why we do this, the reason why you show your work like this, is because you can spot a mistake pretty easy when you go and look over it when you're done, because you need to check your work, okay? Hey, you two, put those away. Focus up here, please. Okay, got it? When you go back and check your work, you can easily spot a mistake if you lay it out nice and neatly. And it does not take you any extra time. Those of you that have poor handwriting, you need to fix it. You need to get on that right now. It's not just, oh, that's just me. I write like this and I can't help it. You need to work at that, okay? Just like you work at anything else, you need to work at writing legibly, okay? Now, some of us have some fine motor skill issues, and I get that. But it still doesn't mean that you can't have numbers and letters that actually are readable. So let's work on that, okay? Very important. Okay, I need to get rid of this negative 2. And this negative 2 is right now multiplied by y. So the opposite of multiplying, because we're doing opposite operations to get rid of things, right? Negative, minus, plus, minus, plus. Multiplying, the opposite is dividing. Yeah. So let's divide both sides by negative 2. Divide by negative 2. That will get rid of this negative 2. Negative 2 divided by negative 2 is just a 1. So that now is just y all by itself. 18 divided by negative 2 is negative 9. So let's just double check real quick. Negative 12. I added 12. 18 divided by negative 2. Negative 9. Okay, I like that. All right. Now the 0 should be pretty easy. Let's see how easy the 0 is. I'm going to make some space here again. The 0 should be pretty easy because when you multiply something by 0, that just makes that whole term 0, doesn't it? So that's 0 minus 2y equals 6. And negative 2y equals 6 divided by negative 2. Y equals negative 3. Negative 3. All right, your turn. You find this one right here. There's 2 ways you could do it. There's 2 ways you could do it. You fill in this one right now. Okay? Take 30 seconds to do that. One way or the other. Actually, do it 2 ways. 2 ways to find this number. You should be able to do it 2 ways. The way I just did these other 2 numbers, but another way as well. So see if you can do that in 2 different ways. All right, let's see. First way, the way I just did the other ones, we could put 4, positive 4, in for this number, and then we'll solve for y. So let's try that. So it's going to be 12 minus 2y equals 6. Negative 2y equals 6 minus 12, right? Because I have to subtract 12. So that'll be negative 6. Y equals negative 6 divided by negative 2 is positive 3. Okay, did anybody get positive 3 here? You agree with that? Okay. Now, what's the second way we could have filled that in? By? Anybody? Using the pattern. Yes. Now, careful. This is plus 4, and this is plus 4. So you have to make sure that that's a consistent jump too. Okay? If that's not a consistent jump, you can't just assume over here. So this is a plus what? 6. So I need to plus 6 here. So negative 3 plus 6, positive 3. Awesome. So 4 comma 3 is a point that's on this line, as well as 0, 3, and negative 4, 9. Any questions about that? All right. So you should be fairly confident with solving for an unknown variable if you are having real trouble with that. If you can't do this over here, you need to let me know. You need to talk to me so I can help you. Okay? All right? I'm not assuming everyone's really good at that. Okay? But you need to come talk to me. All right. So let's plot some points rather quickly here. -4, 9. So I'm going to start at the origin as I always do. I'm going to go left 4. I'm going to go up 9. That's going to put me, oh boy, get my eyes going here. -4, 9, right there. 0, 3, 0, 3, that's my y-intercept. And 4, 3, 4, wait, sorry. Oh, my negatives disappeared. Huh, love that. Disappearing negatives. Okay, -4, -9. 0, -3. And 4, +3. That makes a lot more sense. Straight line. Okay, you'll use your ruler. I'm just going to do this for time's sake. Straight line. Arrows on both ends of the line. Okay, and what is the slope of this line? What's the slope of this line? I can't really see the slope looking at this equation. This is not in slope y-intercept form. It is not, it's not 3. Well, okay. It might coincidentally be 3, but you can't just look at this x value and look at the number there and assume that's it. Okay? So it's not 3 here, but it might seem that's pretty close. So what you would do is, again, remember from the table of values, 6 divided by 4. Do you think that might be it? 6 divided by 4? Or 3 over 2, if that's reduced? Well, let's see. If we remember, the change in y value for all of the other graphs divided by the change in x value was the slope. So how many do I go up? I go up 1, 2, 3, 4, 5, 6, and I go over 1, 2, 3, 4. So that's 6 divided by 4. Yep, 3 over 2. That's my slope. Now that's a bit tricky. That's a bit tricky, but that's how you kind of go slope. I don't think you actually need to identify the slope here, so don't worry too much about that. But what would your guess be as to the x-intercept here? Anybody have an idea? What's the x-intercept? I know what the y-intercept is, 0, -3. What's the x-intercept? If you drew a straight line, what would your guess be as to what the x-intercept is? Right about here. Anybody? I heard it. Say it again, loud.
2, 0.
Beautiful. 2, 0. That's the x-intercept. Yes. Now, would that point work in this equation? Like, could that point be on this table of values legitimately? Well, let's try it here. If I put a 2 there, what would be the partner y value? 3 times 2 is 6. Minus 0 has to be 6. So y has to be 0. Yes, it would work. So 2, 0 is the point that's on this line. Okay. So this form, again, we labeled this form as the standard form of a line. So you can write that down there again if you want. Standard form. And I just want to quickly, in the last 5 or 6 minutes that I have here, talk to you about special cases of a line. Okay, special cases. So if we've been talking about lines that have been slanted, right, like this, either really steep or really small slope or slanted this way. There are some special cases. This line right here, if I were to quickly plot the points that I see on this table of values, it would look like this. -2, 3. -1, 3. 0, 3. 1, 3, 2, 3. So these points are in a line, and they form a horizontal line. Okay? They form a horizontal line. So this is a horizontal line. And notice that what is very striking about the table of values and what is very striking about these points is that 3 is very important here, right? Each of the points has a y value of 3. They all have a y value of 3. So y equals 3 is very important, and as a matter of fact, that is the equation of this line. It's y equals 3. Now you might say to me, Mr. Maxwell, hold it for a second. You said we needed two variables. Well, we often have two variables in a line, an equation of a line, but that's really only for an oblique line. Now, what about the x value here? Well, what this is saying is that the value of x will not change the value of y. So it has no effect. So it's not even in there. You could say technically this. What's the slope of a horizontal line? Well, the slope is exactly 0. So technically, you could write like this, or y equals 0x plus 3. That's how you could technically write it. But because the slope is 0, that means this x term is in effect gone. Okay, so horizontal line is y equals whatever the number is that is the y-intercept. So that's a 3 in this case, so it's y equals 3. Got it? Now, what do you suppose might be the equation of the line here? My goodness. Okay, so this is actually incorrect. That's a typo. This should be, that's totally wrong. The x and the y should be reversed. Sorry. So let's rewrite this over here. Cross that one out. Okay? So we're going to have, I'm going to go 2, 0, 2, 1, 2, 2, and 2, negative 5. I'm going to throw a wrench in there. Doesn't have to be pretty. Doesn't have to be pretty. These points are right here, right here, right here, and way down here. Now those points do form a straight line as well. Okay? Boom. That's a bad straight line. I don't have a ruler. But this is, look at this, the x values are all 2. So what's the pattern there? What do you think the equation of this vertical line would be? If the horizontal line was y equals 3, what's the equation of this vertical straight up and down line? Any idea? X equals 2. Exactly right. This is a vertical line, and it's x equals whatever is the x-intercept. In this case, it's 2. So those are the special cases there. And yeah, we'll have to change this. That's not right. Okay. Now the slope here, okay, the slope. When you isolate y, whatever the number is on the x is the slope. We can't isolate y because it's not really here. Well, we could isolate y, I suppose. This is a little bit beyond. Okay, this is enriched. Ready for this? I could say that I could actually say, I could actually rearrange this, and I could say that 0y equals negative x plus 2. Now, to get y by itself, I would have to divide everything by 0. Dividing by 0 is a big no-no, so we cannot actually isolate for y. Therefore, the number that is attached to the x value for the slope would be, in this case, a negative 1 divided by 0. That's a real problem. And technically, we would call that undefined or infinity. We actually might call that infinity. Something divided by 0 is infinite. So how steep is this slope? Is it really large? Nope. Is it super large? Nope. Is it infinitely large? Technically, it's kind of infinitely large because it's straight up and down. Now, I won't go too much farther into that, but the slope of a vertical line is undefined, or you can say it's an infinite slope. Okay? Like if anyone comes up to you on the street and asks you that, all right? Like pulls a gun on you or something, like, I'm going to rob you unless you can tell me what the slope of a vertical line is. Infinite slope. That person would have to put their gun away and leave. Okay? Because that's the correct answer. All right? So just in case you ever run into problems like that on the street, math will help you. I am armed with math. You just tell them. They'll probably freak out. Like, what do you mean armed with math? What is that? What is that? What are you talking? Okay, fine. Just leave the math in your pocket. I'm out of here. Okay? Something like that. Okay, 4.3 assignment. I bet you're just wondering what that assignment is, aren't you? I know. Bated breath. Okay, so you ready to write this down?
Yes.
Number sign. 1 to 10. Or if you want to write, you can write 1, 2, 3, all the way to 10. 13? Oh, did I hear a complaint? You know, when I hear a complaint, I always just add another question.
I was just glorifying.
17? How do you like that? Is that one good? Oh, another. Did I hear another complaint?
21.
19?
Yeah, 21.
21, you say? Okay, 21. Anybody else?
No, stop it.
How about 50 to 70 as well? Please put that on there. Okay, 50 to 70. Now, I don't think there are 50 to 70 questions, so that was just to scare you. Okay, so that's your assignment.